Okay, continuing on with the example that we started in the last part. Now in part B, we must know, or we're trying to find how far must the nearest defensive player who is 6 feet from the kicker's point of impact reach to block the punt. What we have right here is we have this defensive player who wants to block the football that's coming up this way right here. So how far must he reach? So we want to know the height of the football right here when he's 6 feet away. So we know the x is going to be 6. So we're going to go ahead and find f of 6, and what that value is. That'll be the height of the football when the from 6 feet from the point of impact. So let's go ahead and find f of 6. So f of 6 equals negative 0.01 times 6 squared plus 1.18 times 6 plus 2. Again, I'm going to type that in my calculator, and I get 8.72. Okay, so the nearest football player, the nearest defensive football player, must reach 8.72 feet to block the punt. Or football. So again, so he's right here. He's 6 feet away. We know the height of the football is going to be about 8.72. So if he can reach about 8.72 feet, he'll be able to touch that football and hopefully block the football. So that's really important to know, especially if you're on a football team and you're coaching. You want that player to be able to reach 8 or 9 feet, a little over 8 feet, about 9 feet to punt that or to block that punt. Now the farther away is if he's over here 9 feet away from the point of impact, you have to reach a little bit higher. And the closer he is to the football and the punter, the higher or the lower he has to reach. So if he would don't have to reach that far if he was close to the football. Okay, so let's go ahead and do part C. If the football is not blocked, let's say the punter or the defensive player is not did not touch that football, did not get to block that punt. We want to know how far will that football travel before it touches the ground. So it goes all the way up here. We know it reaches the maximum height. We already figured that out. We want to know how far will it reach before it touches the ground. Okay. So in part C, we want to find when the height is 0. So do you notice that when the football is punted, come back down to the ground, which is right about there, the height of that football is going to be 0. So we want to know when is the height of the football 0. So we're going to do 0 equals negative 0.01 x squared plus 1.18 x plus 2, with the height to be 0. So y is 0. Now I'm obviously going to use the quadratic formula. There's no way to factor this. I'm going to use the quadratic formula here. So x is going to equal negative 1.18 plus or minus the square root of 1.18 squared minus 4 times negative 0.01 times 2, it's on the square root, all over 2 times negative 0.01. Okay. I'm use my calculator. I get x equals negative 1.18 plus or minus the square root of 1.4724. So go ahead and type that in with me. I'm going to double check this, make sure I did it right. 1.18 squared minus 4 times negative 0.01 times 2. Under the square root, I get 1.4724. And in the denominator, I have negative 0.02. So I'm going to go ahead and approximate this right here. Okay, so the square root of 1.4724 about, that's approximately negative 1.18 plus or minus 1.2134 all over negative 0.02. Okay, so we get two values. The first value I'm going to do negative 1.18 plus this, then hit equals, and then divide by this. Okay, so negative 1.18 plus 1.2134 equals, and then hit divided by negative 0.02, I get negative 1.67. And the other one is going to be this value minus this. Then I hit enter and then divide it by this. Please type this in your calculator with me because just copying out what I'm doing is not going to help, especially when you start doing your own work. So type it in and make sure you get the same answer I am. So I did the numerator. I did this negative 1.18 minus this. I got negative 2.3934. Then we divide it by negative 0.02. So I get 119.67. Okay. That should make sense because the height is going to be 0 at 2 points, and the negative 1.67. So actually, this is how this little parabola actually comes back down here. It actually has the height of 0 back here, but that doesn't make any sense logically. But that would be at the negative 1.67. Comes all the way up here and touches the ground. It's going to come back at the ground at 119.67 or whatever you want to round it off 2 feet. Okay, so we're going to disregard this one because the football is not coming back at all. Although we can use that to help graph our parabola. So the football will go down the field approximately 119.67 feet before hitting the ground. And that's only if it's not blocked. If it was not blocked. Okay. So now I want to go ahead and we want to, in part D, graph the function that models the football parabolic path. So we know that the football has a maximum height of 36.81 feet and a curve 59 feet from point of impact at the vertex. That's right about here, the 36.81, so right about there. I'm going to label that as 59, 36.81. Okay. We know that, and actually what we probably want to do is we probably want to find the y-intercept. We want to know where it is right here. And we actually know that because it showed right here. Right here is at 6, I believe. Or 2, I believe. We'll go ahead and figure that out though anyway. So f of 0 equals negative, I'm going to make it smaller, negative 0.01 times 0 squared plus 1.18 times 0 plus 2. That's going to be 2. So we know it's going to have a y-intercept of 2 right there. We know that farthest is going to go down, it's going to come back down here at 119, so right about there. Is that 119.67, 0. And so we know this is the parabolic path of the football. Oops. And again, we know that there's the intercept right here. Again, the football's not coming back, but we know that it would come back here if it was, and that would be the negative 1.1670. That would be the other intercept. Again, when the football is being kicked, the football is actually at a height of 2. The punter is actually holding that football up 2 feet from the ground. That's why it darts right here. Normally, parabola, we have that 2 x-intercepts, if we have any x-intercepts there. Okay? That's a really detailed problem, but it goes through a lot of things here. On your own, when you try this next problem here, and again, same idea, it's just an archer. So we have someone shooting an arrow, and it follows a parabolic path, and there's the parabolic path. I'm going to ask you the same 3 questions, or the same question. The only difference in this problem, there's not going to be anyone to block that arrow, because I don't know about you, but if I were to see someone shoot an arrow, I probably wouldn't want to block it with my hands. Okay, so we're not going to ask that. But a football, it's a little bit different. We can block that football. We can try to block that football, and that's why they ask you. So when you do this problem on your own, we're not going to do this part here where you're trying to figure out how to block the football or how to block the arrow. You're not going to do this part right here. Okay, so we'll go ahead and pause the video. Please try this on your own, and if you can't figure it out, you can go ahead and watch the video and find the answer out. But it's really important that you know how to do this on your own. You definitely have a problem very similar to this one or the previous one on your exam. So make sure that you are able to do this. Okay, so go ahead and pause your video and try this on your own. Okay, to find the maximum height of the arrow and how far from its relief to the curve, I went ahead and tried to find the vertex. And I found the x value to be 200 and the y value to be 205. So the maximum height is 205 feet. And it occurs 200 feet from the arrow's release. So the maximum height is 205 feet. It occurs 200 feet from the arrow's release. Then in part D, it says find the horizontal distance the arrow travels before it hits the ground. So we want to know when did it hit the ground, so then when is the height 0. So it's going to go like this, and come back down to the ground. We want to know the height here is going to be 0. So we know the height is 0, then we're going to go ahead and set the y equals 0, which is your height. And I use the quadratic formula. And got this right here, and did the square root of 4.41. And some students would ask me, how far do I want to take it out? Can I do the square root of 4.1? It goes on forever. I tell students don't round it off one place. If you round this off one place, then your answer is going to be off. You want to round it off 4, 5, 6. Take it out as many places as you feel comfortable doing, but definitely don't round it off one place. Because if you chop it off here, then your answer is going to be off at the end. So I rounded it off here 5 places. And then when I went ahead and found the 2 values, then I chopped it off at that point, because now that's my final answer. So I chopped off one place, or rounded off one place. I got 2 values, and I went ahead and disregarded this one, because the arrow's not going to come back. That would be right back here. And you want to know how far it reaches before it touches the ground, coming this way. The arrow travels approximately 402.5 feet before it hits the ground. Okay. And I found the y-intercept to help me with the graph. So here I have the y-intercept, here's the maximum height the arrow reaches, and here where it touches the ground again. And again, if you want to finish this graph off, you can go back here. And that's where you have the negative 2.5, 0. Again, the arrow's not going to be back here because it's shooting the arrow upwards. So it's going to be above the ground. But again, if you want to look at the parabola, it'll be back here. Okay? That's the end of this section, and so very long section, so this is enough to cover one week's worth of material. So I'm going to have you guys work on the assignment or a mini assignment, depending on if you're in my online class, you can go straight into your homework. If you're in my flip class, you can go straight into the mini assignment. Okay? Any questions, please email me.